We'll explain the method used by 3rd century Chinese mathematician Liu Hui to estimate the value of pi. Pi is simply the ratio of the circumference of a circle to its diameter. And we have the following 3 premises. Premise 1. Liu Hui had previously separately proven the Pythagorean theorem a squared plus b squared equals c squared. Premise 2. The area of a circle is half the circumference times the radius. Premise 3. For a unit circle, the area is simply equal to pi since the radius equals 1. One more note. Liu Hui's results were actually presented in fraction form. In this video, we will simply use his iterations in Excel, since Excel is an easy tool for repetitive calculation. First, we inscribe an equilateral triangle inside a unit circle. This triangle has side lengths of capital X. Then we bisect the lengths of the triangle from the center of the circle, like so. The 6-sided shape, a sexagon or hexagon. These all will have lengths of little x. We'll call this length here little a. We'll call this length here little b. Now we know x is equal to root 3 because we know that this triangle here forms a 30, 60, 90 right triangle, and it has a ratio of 1 root 3, 2. Little x equals the following. Our area for our trigon, or this triangle here, is going to equal to 1/2 the circumference of that polygon times the radius. This has a numeric value of 2.598. This is actually the true area of the hexagon. Now on to the next iteration. The little x's from the previous iteration is now capital X. In this iteration, we start with the hexagon, and then we bisect each side and turn it into a 12gon. So from the last iteration, little x was equal to 1. So now, capital X equals 1. So each one of these sides is capital X. Little x is the length of a newly created side. In the next iteration, we'll use it as capital X and bisect it, and we'll keep doing this in all successive iterations. Now, using the area of the hexagon, we estimate pi. So in just 2 iterations, we're estimating pi to be close to a value of 3. All right. Next, we simply put all the variables we just went over into Excel. Now, we could have used any other spreadsheet, but I've chosen Excel here. You can see that the first column is the inside of Polygon, each representing 1 iteration. The radius r stays the same, which equals to 1. X, we know it's square root of 3 for the first triangle. I just entered that in. Little a has this formula as illustrated earlier. Little b, little x has this formula, and a as the approximation of pi. Now, capital X in the next iteration is equal to little x of the previous iteration as stated earlier. We run through the exercise again, same way. All we have to do, and here's the fun part, is let Excel do all the work. And you can see A gets closer and closer to 3.141592654. Here's Excel's internal value for pi. Polygons have essentially become a circle. Hey, I think that was pretty cool. We've just estimated pi using Liu Hui's method from almost 2,000 years ago. Now let's do a quick percent error check against the pi formula within Excel and see how close we are. Of course, we're assuming the pi formula within Excel is accurate to many decimal places. The error decreases exponentially with each iteration. Looks like by the third iteration, we're already less than 1% error. Alright everybody, I hope you enjoyed that. See you next time.